Hey guys, welcome back. This lesson is on types of reactions. Today you'll identify a reaction type from its equation, balance chemical equations, and then demonstrate a chemical reaction using molecular models. The first type of reaction is a synthesis reaction. This includes at least two substances, like A and B here, that form a more complex compound, compound AB. For example, sodium plus chlorine yields sodium chloride. So when two or more substances combine to form one, we have a synthesis reaction. Here's another example. Potassium plus chlorine yields potassium chloride. The next is a decomposition reaction. In this one, you have one compound that breaks down into multiple substances. Like compound AB decomposes into compounds or elements A and B. Water decomposes into hydrogen gas and oxygen gas. There are exceptions. Carbonates and chlorates, they don't break down into elements. Carbonates, like CO3, decompose to form carbon dioxide and a metal oxide. Calcium carbonate will break down into carbon dioxide and calcium oxide. So calcium oxide is the metal oxide. Chlorates decompose into oxygen gas and a metal chloride. For example, aluminum chlorate will yield aluminum chloride and oxygen gas. Aluminum chloride is the metal chloride. There are other cases too, but we're not going to go over those in this course. Third type of reaction is a combustion reaction. This reaction occurs in the presence of oxygen, generating heat. For example, in the reaction of methane, a common fuel, it will react in the presence of oxygen and burn, producing carbon dioxide gas and water. A single displacement reaction will have a single element that replaces one element in a compound. Now, a cation, for example, will replace a cation, or if this is an anion, it will replace the anion in the compound. Copper chloride and aluminum will produce aluminum chloride and copper. Here, aluminum is single, and aluminum replaces copper, displacing it from its position so that copper becomes the single element and aluminum is then bonded with chlorine. Keep in mind, you may see special cases, such as when water splits into ions, it's going to split into H plus and OH. It does not split into hydrogen ions and oxygen ions. Okay, because H and OH minus hydroxide will combine to form H2O. A double replacement reaction or double displacement is where you have two compounds and the cations will switch places, or if you look at it in a different perspective, the anions will switch places. So in this case, lead nitrate and potassium chromate react to yield lead chromate and potassium nitrate. Let's do a couple examples with models. So first we're going to balance the equation. I have one iron atom here. I have two here, so I'll place a 2 as my coefficient in front of iron. I have 2 oxygen atoms in the reactants. I have 3 in the products. What is a common number for 2 and 3? That is 6. So we're going to put a 3 in front of oxygen to make 6 oxygen atoms, and we'll put a 2 in front of iron oxide to have 6 oxygen atoms. But now I've changed my quantity of iron atoms to 4, so I need to come up here and change this to 4. Now we check our work. 4 iron, 6 oxygen, 6 oxygen. Our equation is balanced. What type of reaction has occurred? I have iron and I have the presence of oxygen. Is it producing carbon dioxide or water? It is not. It is producing one compound, iron oxide. So this is not a combustion reaction, even though there is oxygen present, but it is a synthesis reaction. For example, A and B combine to produce AB. Let's demonstrate this using models. I have iron. I'm going to click on this, right click, and send to back. There we go. I have iron, and it says I need 4 iron atoms. I'm going to pull 4 in here, and you'll have this template available to you so that you can manipulate these as well with me. So split your screen, have my video on the left and your PowerPoint on the right. I'm going to pull in 4 iron atoms into my beaker. Now, how many oxygen molecules do I need? I need 3 oxygen molecules. Red is for oxygen here. And oxygen is diatomic, so I'm going to put these side by side. I have 1 molecule of oxygen. I need 2 more. Here's 1 atom, 2 atoms. Now I have 2 molecules of oxygen gas, another atom, and another atom. And now I have 3 molecules of oxygen gas. Now these are my reactants. For this reaction to occur completely without anything left over, I should be able to use all of these reactants, all of these atoms, to produce these products. What I need to produce is 2 molecules of iron oxide. Each molecule of iron oxide has 2 atoms of iron, 1 and 2, and 3 atoms of oxygen, 1, 2, and 3. Now I need 2 of these because my coefficient is 2. And these 2 molecules represent 2 whole moles, or 6.022 times 10 to the 23rd power of these, but we're just going to use 2 for simplicity. So continue dragging your atoms over until you have made 2 molecules of iron oxide. This is iron 3 oxide. All right, I have no reactants left over. My reaction is complete, and we have modeled this using a PowerPoint. It's a good hands-on demonstration. Let's try the next one. Lead oxide yields lead oxide again and oxygen gas. Let's balance this equation. 1 lead, 1 lead, 2 oxygen, 2, 3 oxygen. I have 1 here, 2 here. That's 3 oxygen. What's the common number between 2 and 3? That's going to be 6. So before I go to 6, I can see here that if I just put a 2, if I start with 2 in front of this oxygen, which there's 1 atom of it, so you're going to want to put an even number here because of the 2 here, meaning whatever coefficient I put in front of lead oxide, I'm always going to get an even number of oxygen in the reactants. So because of that, I'm just going to put a 2 here instead of a 3, and let's see what we can get. Okay, so 2 oxygen plus, I have 2 more here, gives me 4 oxygen atoms. I can make 4 over here by putting a 2. And now I have 2 lead, 4 oxygen, and 4 oxygen, and my equation is balanced. If we look at this type of reaction, I have element A and element B, and they break down into A, B, and B. So because they're breaking down, this is a decomposition reaction. Now it's time to model this reaction. Lead oxide. Here's my lead. Again, I'm going to right click on this image and send it to the back. And I have 2 atoms of oxygen bonded to it, 1 and 2. I need 2 molecules of this, actually 2 moles. Here we go. And these are going to react to produce 2 molecules of lead oxide. So I'm just going to rearrange these now because that's what happens in a chemical reaction is the atoms of the molecules and compounds are rearranged. So I have lead oxide and I need 2 of these. And now I need 1 molecule of oxygen, diatomic oxygen. So oxygen, here we go. Notice that I'm not going to have anything left over. I've used up all of my reactants. The reaction has reacted completely, and I have my products. Let's balance this equation. I have aluminum, 2 aluminum. I'm going to put a 2 as my coefficient. I have 1 copper atom, 1 copper atom. I have 1 sulfate group. I have 3 sulfate groups. I'll put a 3 in front of copper sulfate. Now I've changed my quantity of copper atoms to 3. So in the products, I need to put a 3 as my coefficient. 2 aluminum, 2 aluminum, 3 copper, 3 copper, 3 sulfate groups, 3 sulfate groups. Check. What type of reaction has occurred? Well, we'll call aluminum A, copper can be B, and sulfate can be C. Aluminum is A, sulfate is C, and copper is B. So aluminum has displaced copper. Copper is now single, so this is a single displacement reaction. All right, it's time to model. We're going to take 2 moles of aluminum. I'm going to need to right click and send this to the back. Okay. And these are individual, so don't connect them. Now for copper sulfate, I need 3 copper sulfate molecules. Here is copper, and here is sulfate, SO4. I'm just going to add them together there. They are bonded. I need 3 of them. All right, now they are going to react to produce aluminum sulfate. So here is aluminum. There are 2 aluminum atoms in the molecule, and it says there's 3 sulfate. How am I going to combine all of these? My goodness. Aluminum. Another sulfate group. Okay, we're going to delete that. We don't need that beaker. You get the idea. All I want you to do is at least make these touching so that you can show a full molecule of it. Okay, 2 aluminum, 1, 2, 3 sulfate groups, 1, 2, 3. They're all touching, and now I have 3 single copper atoms. 1, 2, and 3. Voila, these are the products. By the way, aluminum sulfate is used in fertilizer. For example I, we have hydrogen gas reacting with oxygen gas to produce water. Let's balance. We have 2 hydrogen atoms in the reactants, 2 in the products, 2 oxygen atoms in the reactants, 1 in the products. We'll put a 2 here so that I have 2 atoms of oxygen. That's changed my number of hydrogen to 4, so I'm going to put a 2 in front of hydrogen so that I have 4 atoms of it. Let's check. 4 hydrogen, 4 hydrogen, 2 oxygen, 2 oxygen. Our equation is balanced. What type of reaction is occurring? I have hydrogen, which I will call A, oxygen can be B, and dihydrogen monoxide can be A, B. So this is a synthesis reaction. But it's also another type. Notice that we have oxygen as a reactant and water as a product. That means this is also a combustion reaction. Hydrogen will react in the presence of oxygen and heat will be given off, but you won't be able to see that in this equation because it's on paper. But when they react, they produce water vapor. Let's model this. We need 2 molecules of hydrogen. That is 1 molecule. It is diatomic, H2. Here's the second molecule. I need 1 molecule of oxygen. There it is. And now the reaction will occur, and I should end up with 2 molecules of water, H2O. Voila, no reactants left over. It is balanced. If you'd like to see this demonstration in a different way, you can click on these 2 links. One more example for you. This one involves hydrosulfuric acid combining with oxygen to produce sulfuric acid. We have 2 hydrogen in the reactants, 2 in the products, 1 sulfur in the reactants, 1 in the products, 2 oxygen in the reactants, 4 in the products. Let's put a 2 here so that we have 4 oxygen atoms in the reactants and 4 in the products. That ends my train of thought, so let's check. 2 hydrogen, 1 sulfur, 1 sulfur, 4 oxygen, 4 oxygen. Balanced, 1, 2, 1. What type of reaction is occurring here? I have hydrosulfuric acid, which we'll call A, B, combining with oxygen, we'll call this C, and then we get A, B, C. We have one thing that is formed as a result, so this is a synthesis reaction. Let's model H2S. I'm just going to delete the beaker. We know it's a reaction occurring in a beaker. I'm going to delete that box too. I don't need that. H2, 1S, hydrosulfuric acid. I just need 1 of those. I need 2 molecules of oxygen. 1, 2, that is 1 molecule. 1, 2, that is the second molecule. Now these react to form sulfuric acid, H2SO4. All right, so let's make the sulfate group first. And we need 2 hydrogen touching this. So I'm just gonna put this one, I'll put this one on top of sulfur here, and I'll put this one like behind it. Send 2 back. There we go. Now, wasn't that fun? I want to give my visual learners one more way to look at chemical equations. Here I have sodium sulfide, hydrogen chloride reacting to form sodium chloride and hydrogen sulfide. So I'm going to take and build sodium sulfide first. Now I'm going to take 2 atoms of sodium, and they're going to bond with 1 atom of sulfur. Okay, then I'm going to go ahead and build a molecule of hydrochloric acid. I need a Cl, I need an H. Okay, now these are supposed to react, and they're supposed to react completely so that I don't have any excess left over. And they're going to form sodium chloride and hydrosulfuric acid. So I'm going to take and rearrange these atoms to form sodium chloride. There, I made 1. That's satisfying. Now I'm going to make hydrosulfuric acid, 1 molecule of it. Uh-oh, I got a problem. I need another hydrogen atom. I can't just throw 1 hydrogen into the reaction and call it good, because hydrogen in the reaction is in the form of hydrochloric acid. So I need to add a whole molecule of hydrochloric acid. to my reaction. Now that can react with this free sodium ion here to form another sodium chloride molecule. So there's that. And now I have that second hydrogen that I needed to make a full molecule of hydrosulfuric acid. Next, I can balance my equation just by looking at what I've made with my models. I have 2 molecules of sodium chloride, and I have 1 molecule of hydrosulfuric acid. Now these represent a whole mole of these, a whole quantity. Now, what did I use? Well, I had this sulfur here, which was bonded to 2 sodium atoms. And I had 1 of those. And then I had used 2 molecules of hydrochloric acid. Now I just want to double check this balanced equation to prove it to myself. So 2 sodium, 2 sodium, 1 sulfur, 1 sulfur, 2 hydrogen, 2 hydrogen, 2 chlorine, 2 chlorine. It is balanced. So that's another way that you can think about solving or balancing a chemical equation. So draw your models first and see how many reactants you need and how many products you can form. What type of reaction has occurred here? I have sodium, which I'll label A, sulfur I will label B, hydrogen I will label C, and chlorine I will label D. Over here, sodium is A, chlorine is D, hydrogen was C, and sulfur was B. In this reaction, A and D combined, which means B and D, my anions in each compound, switched places. So that A could bond with D, and B could bond with C. This is a double displacement reaction. Okay, on the problem set, I want you to do 1 through 23 on the portion called Balancing Equations Basics. If you have any questions, just send me a message. Here are 2 self-quizzes you can take online. They go along with your textbook. Have a great day. I want to show you how to save your PowerPoint after you've completed it. Go up to File, and now if you're on a Mac, this is at the top. If you're on a PC, follow along. So find File. Now you can either click Save As and then click PDF, or just go to Export and save it as a PDF. So I'm going to go to Save As, Browse, and here I can change my file type to PDF. This is going to save it so that none of your items or atoms, for example, get moved. None of your text boxes get moved around. So I'm going to put this on my desktop here. And that should be it. So again, you can export your file as a PDF to prevent any of your images or text boxes from being moved when you transport this through like an email or through Schoology or any other program.